send out a applications form to kind of fill in, looking at your hydrogen usage rate, your generator cavity purities, things of that nature. And if you wanted a full solution, we would generate an application note similar to this. We would look at roughly the layout of a potential system for your facility, and then look at savings under the different aspects of a hydrogen solution. So under the stable flow solution, there'd be a section. This facility's unit 5 had an average hydrogen purity over time of 97.7% pure hydrogen. Our stable flow system would bring that up to 99.5% with a reduced windage loss of 450 kilowatts. Now you'll say, well, you were saying 250 kilowatts per percent, that doesn't add up. Well, in our calculations, we take into account if your generator is not at 600 megawatts. That 250 kilowatt per percent savings was based on 600 megawatt plant. So if your plant's 400 megawatts, then the 250 comes down a little bit. If you're a 250 megawatt CT plant, that comes down more. So it's ratioed based on the size of the electric generator, just so you're aware of that. So in this case, it was 450 kilowatt savings based on hydrogen purity alone. So the electricity loss avoided for a year, 3,500, a little over 3,500 megawatts. And considering $45 a megawatt hour sale price, you can see very close to $160,000 in savings. Here's some windage loss alone for this facility. We further looked at hydrogen cost savings for this facility. Generation costs at this site, using a hydrogen generator, just under 60 cents per 100 cubic feet of hydrogen. They're paying, because this was an assumption based on the information we had at the time, $6 per 100. There's a huge savings, 10 times savings in hydrogen alone. And to that, you can count all the safety benefits that, unfortunately, you can't always tag cost benefit to, but certainly in the long run, it'll benefit the whole facility. So in this case, almost $50,000 in hydrogen savings over a year. Adding those two items together, a single solution, generator, stable flow system for this site, almost $210,000 in annual savings. And the good news from our perspective, the hydrogen generator and stable flow system solution, at those type of savings, your payback will be under 2 years. Not including installation costs. With installation costs, you'll probably be right about the 2-year mark, I would estimate, typical installation. And so those are our key benefits. There's safety improvement associated with on-site generation. There's a benefit on windage loss and reduced either CO2 output or a slightly better output of your generation systems, all in a single solution that we can assist with through Proton. And happy to take any questions.
What are the cooling water requirements?
Quite low, 35 gallons per minute, worst case.
I mean, we usually use raw water, river water.
That's
Is
fine.
there a cleanliness requirement or anything like that?
Yeah, that'll be fine. You have a strainer upstream. It's just a small plate-and-plate heat exchanger inside there. It's not a problem.
What's done with the oxygen that's generated?
Yep. The oxygen, I talked about the full the air circulation through the plumbing side of the cabinet. That oxygen is vented into the cabinet and completely diluted before it exits. The cabinet. So you never have to concern building up an oxygen-enriched environment.
Maintenance costs?
Maintenance costs, $3,000 a year for a larger hydrogen generator. And that maintenance cycle is broken into preventive maintenance kits over a 3-year cycle. So at the end of year 1, you put in the first annual kit. It'll probably be about a maximum 4-hour process. At the end of year 2, you put in a 2-year kit. 4 to 6 hour process. End of year 3, the 3-year kit. Maximum of 8 hours in the 3rd year. And then in the 4th year, you revert back to the first year kit. So on average, those are $3,000 a year.
Let's say if you have a plant with, say, 4 generators or 6 generators, could you put in a smaller system, the S-series on each
You could.
generator, and then plumb those together, so if you had to purge a machine, so you'd have all of those feeding the one machine?
You could.
Can you do something like that?
Sure.
Have y'all seen that done?
We haven't seen it done. The sites I'm familiar with that have looked at a similar type solution, the economics weren't quite there to justify purchasing the 3 or 4 generators. There's one site I can think of in Maryland. It worked out that they put the S-series generator on each of their power islands. They had 3 power islands, and that was more cost effective than to plumb the 3 islands together into a single large hydrogen generator. But pretty sure they did not plumb them all together for regassing. In a regassing application at that site, they would call ahead and bring in a tube trailer if they needed it.
Our generators typically use, say, 300 to 500 cubic feet a day,
Okay.
routine losses.
Sure.
So, I mean, if you got one of these S-series, that will provide that,
Mm-hmm.
plus about 500 cubic feet more.
Mm-hmm. It'd certainly be ahead of the game.
What's the difference in cost between the S-series and the H-series?
The largest S-series would be in the $95,000 range, and the largest H-series would be around the $200,000 range. As far as looking at, cost efficiency, it's better to put in a larger generator up front, if it makes sense, than to do the smaller individuals, if you looked at that.
I would say a generator that's 3,000 cubic feet volume, that H-series could purge it in 12 to 15 hours.
Yeah. And do you typically purge faster than that in your facilities?
Yeah, it's usually about an 8-hour process.
Okay.
And that gets into a time is money
Exactly.
proposition if you're sitting there waiting to purge.
Yeah.
Which a lot of times it doesn't really matter. But there are some times when that's your showstopper.
Absolutely. And to be honest, we haven't seen many facilities put in just hydrogen generation and use the hydrogen generation to regas the generator. I can't think of too many that have done that. Most people would put in the hydrogen generation for the daily makeup, and then they would have some alternate. Maybe they bring in a tube trailer for an outage, or a small tube trailer. Some of the small sites, they would go with maybe an 18-pack the once a year that they're in an outage kind of thing. Other than that, they've been able to completely separate their ties from delivered hydrogen. Other than maybe the once a year outage. Pleased with that from a safety aspect.
I think you have to do some study and all that.
Absolutely.
Some numbers and see what would be best.
Mm-hmm. It amazes me how every site is different.
And this could also get you away from having to have a dryer.
The stable flow system does have a benefit on the drying side, absolutely. It's
Lead and feed with this.
yeah. Correct. It's bleed and feed, and the great thing about it is it's fully automatic, so your operators don't have to intervene. They can just monitor it from the control room, and the system automatically maintains pressures within the target range, purities and dew points within the target range.
Yeah, we've got a plant Cumberland that has the old single chamber dryers, and we were thinking about putting dual chamber dryers in, but this might be a better solution.
This might be a good solution there. You get some drying benefit. It's not going to handle large cooler leaks. We were talking about that the other day. But the great benefit is it has some purity capability. security control capabilities.